Hello everyone, my name is Darren Kwasasi from 12 Matthew, and today I would like to present to you my geographic assignment video, which is about remote sensing and GIS, Geographic Information System. What is remote sensing and GIS? Remote sensing is the process of observing and gathering information without touching or visiting the area through the usage of satellites or aircraft cameras, which reflects and emits radiation upon reaching the Earth's surface. There are two types of remote sensing, active and passive. The active remote sensing produces its own energy and use the internal stimuli to collect the data of Earth, while passive remote sensing obtains energy from absorbing the sunlight and use the external stimuli to record the energy that enters the Earth. GIS, aka Geographical Information System, is a form of a framework that is used as a way to gather, manage, and analyze spatial and geographical data. The GIS is very important since the technology, policy, standards, human resources, and related activities are necessary to acquire, process, distribute, use, maintain, and preserve data. As you can see here, I have the picture as example of remote sensing and GIS. The remote sensing picture shows the sun emitting its radiation into Earth, and the satellite receive those radiation and absorb the information from the radiation. And over here, I also have the example of active remote sensing, which produces its own energy, and the passive remote sensing, which takes the energy from the sun. And over here, the GIS, Geographical Information System, I have shown the data that is being taken for the Geographical Information System. The usage of remote sensing and GIS. Remote sensing is generally used as a way to collect and gather data in the Earth surface such as hydrology, ecology, oceanography, glaciology, and geology. In addition, remote sensing can be used to detect energy from the wavelengths that can or can't be detected by the human eye, such as infrared, ultraviolet, and X-ray lights. GIS is used as an inventory and the management of resources, crime mapping, establishing and monitoring routes, managing networks, monitoring and managing vehicles, managing properties, locating and targeting customers, locating properties that match specific criteria, and managing agricultural crop data, addressing public health concerns, mapping wildlife risk and preparedness, integrating a remote sense image, and mapping, monitoring, mitigating invasive species. Now, the components of and elements of remote sensing. The components of remote sensing includes energy source. It illuminates and provides electromagnetic energy to the target. Atmosphere. It absorbs, reflects, and passes electromagnetic radiation due to the presence of O2, CO2, nitrogen, hydrogen, and helium. And then the interaction between the energy and the object. It can be seen from the tone produced by aerial photographs. Sensor, a monitoring device installed on a vehicle, both aircraft and satellites. It is classified into two, such as photographic and electronic. Transmission, reception, and processing. The energy recorded by the sensor has to be transmitted, often in electronic form, to a receiving and processing station where the data are processed. Interpretation and analysis. The processed image is interpreted visually and or digitally or electronically to extract information about the target. Application. The final element of the remote sensing process is achieved when we apply the information we have been able to extract from the image. Now, here are the pictures that shows the component of remote sensing and the process. So please take note. Now, the results of remote sensing. As you can see here, I have two examples of the results of remote sensing. Over here, I have the results of remote sensing or aerial photography over a specific location, which details about the buildings, the grass, and the trees, and also the road. While over here, I have another type of remote sensing, which details about the area next to the watery area, vegetation land, and the mountainous area. The image interpretation of remote sensing. As you can see from the picture over there, that is the results and the image interpretation of remote sensing. According to Cowell, 1997, photo interpretation can be defined as the act of examining photographic images for the purpose of identifying objects and assessing their significance. This is actually true since remote sensing requires images to be viewed clearly in order to be used to gather data and information. Image interpretation comes in the form of photographic and non-photographic. The photographic version uses aerial camera, which can also be said as aerial photography. The non-photographic version uses a sensor from the satellite and it's called as satellite photos. Now, the elements for images interpretation. We have tone and color, the level of darkness or the level of brightness of the object in the image. Shape, a qualitative variable that describes the configuration or framework of an object. Height, also known as elevation or bathymetry, is one of the most diagnostic elements of image interpretation. Size, an object attribute in the form of distance, area, height, slope, and volume. Pattern, the spatial arrangement of objects in the landscape. Shadow, it hides the details and or objects that are in dark areas. Texture, it is a characteristic placement and arrangement of repetition of tone or color in an image. Sight, it is grouped into a higher complexity and is related to the surroundings. Association, the relationship between one object and another. Now, the advantages and disadvantages of remote sensing. The advantages, data can be managed in a clear format, cheaper cost than field survey, and data can be recalled and repeated quickly. The disadvantages, it is expensive to analyze repetitive photographs to analyze the different aspects. The image could be interfered by other phenomena during the processing stage, and the instruments used in the remote sensing may sometimes be uncalibrated. The components and elements of GIS, Geographical Information System. There are at least 5 components for GIS. Hardware, the computer that GIS operates at. Software, it provides functions and tools and that process the information. Data, the most important component for GIS to integrate the data. People, the people manage the system and develop plans. Methods, a GIS will turn out to be successful with a well-designed plans and business rules as a method. And as you can see through the picture here, I have the 5 components and elements all together. Now, the 10 stages of GIS system. Well, even though it's a bit much, here I managed to summarize it in my own words. The preparation stage is where the GIS begins its own process before going to the map digitizing stage, where the map is being digitalized and being processed. Then the editing stage, where the informations and the images are being edited in order to see a better view. The converting stage, the information and the data is being converted into the system. The annotation stage, it annotates the information and the data and combine it into one. The labeling stage, the labeling stage is where all the images and the data in within the map is being labeled according to the place and the locations that has been taken. The analysis stage. It is where the places and locations within the map is being analyzed and being researched. The buffering stage. This one is probably the stage where the map is hmm, being put together. The reporting stage. This is where all the informations being after being processed, it's being reported and being put into the web information where many people can access it. The benefits of GIS. The following are the benefits of GIS. It's to make an inventory of natural resources, simplifying planning development patterns, can display maps in 3 dimensions, can speed up the process of dropping the map from the previous map, simplify and speed up the data manipulation process for spatial planning and regional development, obtaining information regarding the environment, population, socio-economy, land management, etc. Finally, we reach to the advantages and disadvantages of GIS. The advantages, it has the ability to improve the organizational integration. It allows viewing, questioning, understanding, visualizing, and interpreting the data into a number of ways. The technology can be integrated into any framework or any enterprise information system. Spatial and non-spatial data can be managed together. Data analysis and data changes can be carried out efficiently. Data can be displayed in 3 dimensions. The disadvantage, it requires enormous data inputs amount that are needed to be practical. There would be geographical errors in the interpretation. The software is incredibly expensive. Human resources are required who must master GIS technology and related device. Information system must be continuously updated according to technological advances. Data structures are complex and difficult to manipulate. And so that's the end of my geographical video presentation. I'm sorry if there's any less information or if there's anything missing. But I guess I have done my best. Thank you for watching my presentation and see you later.